So first, I'm going to ask, what are some high-performance HVAC systems that Michigan cultivators should consider? Note that, again, this is a workshop where we're focusing on scientific concepts and the things that you can bring to your partners and to your design team. And so we're going to talk about specific products here in an array of product families. So here's some pictures of some pieces of equipment. I'm going to ask first, Nick, if you wouldn't mind, as a non-manufacturer member of the panel, kind of giving us an overview as an engineer. What are we looking at here? Where's the air going? Where's the water going? What are some choices that people have on the table for high performance equipment in cultivation facilities?
Sure. Yeah, absolutely. And, you know, each of these have certain key elements that help them be good options for, you know, indoor cultivation. So the top two on the left is the air-cooled chiller. You'll note that this also has free fluid coolers. And on the top right, you have, which is probably a water, those look like air-cooled condensers. You got a 4-pipe chiller system, heat recovery, okay, via air or water side economizer. So really what we're showing in the top right is that you have a 4-pipe chiller system, in that you can be economizing on the air or water side, meaning the chillers may be cooled to the ambient air, or they may be cooled through cooling towers. What's nice about chillers is that you have a degree of control over the chilled water temperature that you send from the chillers into your process. And that ability to not only change the temperature of the chilled water coming out of the chillers, but also to mix that with hot water allows you to really dial in the device air temperature or the supply air conditions that are being delivered to your space. So a typical like rooftop unit, direct expansion rooftop unit, it's really just going to deliver the air to your space, certainly under essentially one condition. With a chiller system, you have the ability to really dial in what is it that you are delivering to the space. Chillers also provide the opportunity for free cooling. So an air-cooled chiller, you can essentially shut off the compressors of the chiller system, send that cooling fluid, your chilled water with probably some glycol mixed in, out to basically big radiators outdoors with fans. And when the weather is cold outside, you can cool your facility, get the cooling loads that you need without running the compressors, which are the big energy hogs of the system. On the 4-pipe side, similar, though you can economize either through these dry coolers, if it's an air-cooled chiller, or right through a cooling tower with water side economizing. So those two systems give you a lot of opportunity to fine-tune the conditions of the air being delivered to the space, and for free cooling in those cold weather climates. And that can take a lot of energy, typically associated with cooling right off.